Featuring prominent industry vendors, moderated by an independent analyst, Solutions Review presents the Expert Roundtable, an in-depth panel discussion focused on solving strategic enterprise challenges.
I'm Doug Atkinson here at Solutions Review, and welcome to this Expert Roundtable, enabling AI at scale through Lakehouse data quality and orchestration. While McKinsey's latest research estimates that generative AI could add up to $4 trillion in annual economic benefits, the recipe for AI success can be complicated, and the secret ingredient is well-orchestrated, high-quality data. For this panel discussion, we have brought together two leading data software builders, Pradeep Anandapu, Senior Solutions Architect at Databricks, and Zach Wright, Solution Engineer at Anomalo. Our expert panelists will explore the latest trends in modern data quality and orchestration in lakehouses, and how the synergy of these capabilities is essential to AI success. To drive this conversation, we have invited Senior Data Management Strategist Robert Eve. He is a former tech CMO and currently an industry analyst helping data-driven organizations optimize strategy and execution via deep domain knowledge and market insights. Bob, I'm going to turn it over to you now. Thanks for being with us.
Thank you, Doug. Welcome, everyone, to today's Expert Roundtable. Yeah, the subject of AI is everywhere, and enabling it at scale is becoming more and more important. So the question is, how do you do that? Where are we going to focus? On what areas? Where to make the investments and that sort of thing. And today, we're really going to drill down into data orchestration and data quality in the environment of a data lakehouse and how that will work to enable you to do AI at scale. As Doug mentioned, McKinsey's come out with studies talking about the $4 trillion AI opportunity. So of course, your board and your enterprise IT teams are all over this as a business opportunity. And in fact, progress is being made. According to Gartner, over 20% of organizations have made substantive progress on generative AI use cases and applications. In terms of actual implementations or full-on pilots. And another 70% are planning to move forward. And they're going to invest. It's $143 billion in the next couple, in 2027, according to IDC. And so it's not really a question of whether to do it. It's a question of how to scale. If you're that 20% that's already in, and you want to take your existing use cases and expand them. If you're part of the 70%, you want to put in a solid infrastructure so that you will be able to scale later. And that's really why we're focusing on data quality and data orchestration. Because whether it's AI at scale, or whether it's analytics at scale, or e-commerce at scale, or anything, ERP at scale, you can only do that on a foundation of data, that well-orchestrated, high-quality data that your business can access and trust. And so we're really going to go back to basics today and focus on a couple of really key areas of getting your arms around the data and enabling that so that you can have that success with AI in general and AI at scale. And to do that, we've brought in a couple of experts from leading vendors, Zach from Anomalo, modern data quality, when these new generations of data quality organizations, platforms, and then Pradeep from Databricks, and probably the hottest company in data management right now. So let's begin with some introductions. Zach, you want to go first? Tell us about yourself.
Sure. So thanks for having me. My name is Zach. I'm a solution engineer at Anomalo, and my background is in data engineering, QA, analytics, BI. I used to do data engineering in finance at Capital One, as well as in web analytics. And my previous position was at Tableau as a solution engineer. So suffice to say, my entire career has been completely plagued by data quality issues. That's why I'm here.
Pradeep?
Thanks for having me as well. I'm part of Databricks, of course. I'm a partner solutions architect here. I usually work with partners like Anomalou to help them build integrations with Databricks Lakehouse platform. I've been working in the data space for more than a decade now, and it's just like Zach, I've been I'm pretty familiar with the data quality issues and stuff like that. So yeah, I'm very happy to be on the call today.
Thanks, Pradeep. Well, let's start with you and let's set some foundations. And I think the first foundation we need to set and make sure everybody has a good understanding of this idea of the data lakehouse. Relatively hot topic in the last couple of years, emerging topic. So maybe you could take a few minutes and kind of give people the foundational understanding of what's a lakehouse, what's different about that.
Yeah, absolutely. Essentially, I mean, in the past, you might have heard about data warehouses, and then needs changed in the industry, and then we introduced data lake to the industry. Not Databricks, but just in general, data lakes were introduced, and then there were two separate or parallel platforms that a lot of companies started maintaining: a data warehouse for data warehousing needs, and then data lake for a different type of needs like machine learning or machine learning and AI. So what Databricks tries to solve is basically the data silos that occur due to having these parallel platforms. And we call these organizations that are adopting Lakehouse data forward organizations because of that. So essentially, I'll try to explain, just give you guys an overview of what Databricks has done so far, and then how it solves this Lakehouse, how it solves this problem with a Lakehouse platform, right? So Databricks originally, the creator of Delta Lake, Apache Spark, which most of you might have heard of. And we got MLflow. We're more than 5,000 employees right now globally, and we are the inventor of the data lakehouse. So let me just get into this. So a data forward enterprise means making sure AI and data are in every part of your business. That just means that it could be part of the customer lifecycle, product and services, workforce productivity, business operations, doesn't matter. It should all be unified, and data and AI should be powering all of these capabilities across your organization. Now, data forward enterprise, just means this graph would basically give you that explanation here. So previously, like I said, companies used to be data siloed, and then slowly things started getting better, but still they're not there yet. Right now, every organization has moved to the right, trying to solve a little bit more than historic reporting and then predictive analytics. Now they're into AI, but all of this is not really unified, and AI is not really enabling every aspect of their business. So that's what we call data forward, and we're hoping to solve that challenge for all the enterprises across the world. So basically, this is the reason why companies are not able to move to the further towards the right. Basically, they have a data lake, a data warehouse. There could be an orchestration platform. There could be a business intelligence platform, data science, ML platform, streaming, governance. There are so many platforms that they have to stitch together to make this happen, and which is, I'm sure you can understand, that creates a lot of silos and inconsistencies, etc. So it's all unnecessary, expensive, and complex. And data lakehouse takes a different approach, right? So we basically have one platform that stores all the types of data, right? Structured, semi-structured, unstructured, and then we have a single governance model, security and governance model, to access this data across the organization. And we support all workloads on the same data, may it be BI and data warehousing workloads, data engineering workloads, streaming, data science, and ML. So all the workloads on all of your data unified in one place. Could be part of any cloud, it doesn't matter, right? So we solve this by these products, right? We have something called Delta Lake that enables the storage of different formats of the data, and Unity Catalog on top of it for governance, security, and governance, and then different products for working with these workloads. Example being Databricks SQL for SQL workloads, and then we got Databricks Workflows, which we will talk a little bit about during this session. So that's basically the Databricks Lakehouse. And of course, we have a lot of partners that we build integrations with. And as you can see, Anomalo is one of them, right? This is what shows, right, what is available today with Databricks. And essentially, Databricks is the only platform today that offers a complete lakehouse. There are some lakehouses out there, but they're not still complete. There are a lot of offerings that are missing. That's what it is.
Great. Thank you, Pradeep. So basically, the Lakehouse concept, infrastructure, unifying the data silos, unifying the platforms, integrating in partners such as Anomalo, to kind of provides a really solid foundation on which to then create AI and then scale it subsequently. Zach, let's switch over to you. Let's talk about data quality. Data quality has been around. Data quality, the problem, and data quality, the solution, the platform, have been around a long time. But what's new and different about today's data quality? Why is it that people need to think about the problem and solve it in a new way?
Yeah, so that's a great question. If we have bad data quality, it's going to be difficult to make intelligent business decisions if we have wrong data to go off. So that part's the same. What has changed a lot over the past few years is the amount of data that we're working with, the amount of tables, especially the whole concept of a lakehouse, where we have just so many different sources of data in Databricks. And the issue that we generally see customers and prospects and architects in a lakehouse face in data quality is rules are difficult to scale. So if they have validation rules for anything that could go wrong in any single column, in any single table, that's going to be a lot of effort to set up, particularly across tens of thousands or even hundreds of thousands of tables in a lakehouse. And not only that, those rules are brittle in that data changes over time. And then we're going to be getting a lot of alerts, a lot of notifications, and it's difficult for users to pay attention to those data quality issues. And so they go unresolved. So that's generally the large problem that we've been seeing today, and mainly in scalability.
So those rules, like the old rules, a zip code has to have five numerics. That's a great rule. That's very simple to implement. But the problem is there's all sorts of tables and rules and keeping that straight. So you need a different approach than a rule-based approach. How is it that you guys approach it differently then?
Yeah. So I think the best way to put it is we need a fuller, comprehensive strategy for data quality monitoring. Rules, there's always going to be a time and place for those. They're not going away. There's certain things that are absolutely critical. For example, a credit card company can't have someone's social security number wrong or an address in that field. That's critical, and we need a very hard and fast deterministic rule there. But there's going to be the unknown issues that we're not going to find. And that could be data drift of all different types, like significant spikes in missing values like nulls, zeros, empty strings in different columns. And that's going to be different for every column. One column might have 50% nulls as a standard, and one might have 5% nulls as a standard. We need dynamically changing thresholds to detect those significant shifts. And that needs to be automatic. There's also going to be value drifts, like the averages or quantiles of specific numeric columns. That could be like the average credit card spend of a credit card company. So we need a way to automatically do that. And the best way to do that is through unsupervised machine learning. And how we would use unsupervised machine learning is we take a sample of yesterday's data and we compare it in clusters to historical data. And when we do that, we're asking what type of drift is happening and how extreme is that drift. And sampling is used because it's extremely computationally, it's not going to take a lot of computational power, and it can still detect significant drift. So with that baseline that happens, we don't need to create a check for anything that could go wrong in every column and every table. We're getting foundational deep data quality monitoring. So where legacy data quality platforms or other data quality platforms might be automatically looking for things like the data isn't arriving on time or it's not complete, we're not getting the expected number of records, that's not enough to determine if there are actual data quality issues on a large scale. I think the other part, which I'll go into a little bit later, is we need a quick way to resolve issues. So it's not enough to just detect them, but we need to get alerted on them without too much noise. And then finally, we need to resolve them in a quick way. So here at Anomalo, in the platform, there's an automated root cause analysis. So that's going to be generated when a data quality issue is detected.
So when you say automatic, I'm just going to summarize for the audience. First kind of automatic is being very smart about automatically detecting issues and problems, and then being very smart about automatically resolving them. Because if you're really smart about finding problems and you just generate lists and lists and lists of problems for a data engineer to go work on, that's not scalable at all. You need to have automation on both the discovery and the resolution, and you guys have achieved that.
Yeah, I think that's a good way to put it. There are different levels of automation. Again, there's the pipeline automation. Rules are going to be, we can set them up to run every day. And then there's even going to be key metric checks, which are maybe a higher degree of automation where they're looking for significant anomalies by using time series models. But again, there's going to be so many different metrics across a warehouse that we need a way for deep monitoring without any type of configuration. To say, oh, hey, I want to monitor all the tables in the schema, and please let me know if there are any significant issues in drift of some way. So it's a whole new paradigm in the way we monitor, where we could get that blanket data quality monitoring and focus only on creating checks that are deterministic or looking for anomalies in time series models for a smaller subset of the important data quality issues.
Great. Thanks, Zach. Pradeep, let's switch back to you and talk a little bit about orchestration. When we're talking about all of these silos, right, coming together and unifying the data and unifying the platform, and that is by definition, orchestration is to orchestrate is the verb that describes that bringing together effort. Is that right? And why don't you tell us a little bit more about what is data orchestration?
Yeah, absolutely. So how I view data orchestration is, we have in a data lifecycle, data goes through different sorts of workloads, different sorts of tasks. It could be in different platforms in many cases. Data orchestration basically solves the challenge of being able to tie all of those tasks together and be able to monitor it, monitor each step, and as a result of it, be able to solve issues wherever they happen. So Databricks takes a different approach to this. We actually have the data orchestration product as part of our platform. So it's not a separate platform or anything like that. Because it is part of our platform, it enables a lot of UI workflows that basically make it easy for any persona to be able to orchestrate their workloads, right? So that is what Databricks solves. So essentially, we see a lot of organizations having that even work with Lakehouse that have orchestrators that are external to the Lakehouse. It could be something like Airflow, right? They most probably orchestrate across different platforms. But with Databricks workflows, we can orchestrate external stuff as well, but it's essentially built for, at this point, built for all the products within Databricks. You should be able to work with them and also orchestrate on a single pipeline, end to end, from ingestion to AI. So
you said something very interesting, Pradeep, and that was the any persona. Let's explore that for a moment.
Yeah.
We're talking about a lot of orchestration required, a lot of data sources, a lot of transformations, a lot of journeys, including data quality, a lot of journeys to get to that AI model. And so big problem. Good answer is divide the work, right? If all that work had to be done by a select group of data engineers who could only work with a limited, very highly technical product, a very deep but technical product, that's one way to attack the problem. It sounds like if you can do any persona, maybe you can you guys get the citizen data engineers to help people rolling up their sleeves and helping address this and kind of broaden the user community to kind of bring intelligence to the challenge?
Yeah, there are two ways organizations approach this usually, right? They could have a all-star engineer that's like, they have expertise in all areas and they handle end-to-end. They're able to, resolve issues end-to-end, no issues, right? But there are other organizations that take it in a different approach where, data engineering team, works on making the data available, and then you got analytics engineers, new persona, or like a analyst that's trying to transform this data and make it business ready, and ML engineers, working with this data, building models on top of it. So they're dividing these tasks, but the orchestration of this data is happening on a single pipeline. So they could be owners of that part of their pipeline.
Got it.
And still be able to tweak the orchestration for their product as it needs to be. So that's and then a single person, of course, owns the entire pipeline, but they're individually handled now. And since different personas have access to that orchestration piece. So that's how I see it. And a lot of organizations are definitely taking advantage of that right now. Yeah.
Well, that makes a lot of sense, and especially since you showed a diagram with the data sources at the bottom coming together. It's always a silo out, right? Because now we have this data that goes out to all these different use cases, and so we need to have almost different sets of skills and different sets of thinking for the last mile than the skills and thinking required for the first mile. That's good that you've got both parts covered. So let's bring these two together, orchestration and quality, in the context of this lakehouse. Zach, I know you have some slides that kind of can help us bring that concept together.
When we talk about the modern data stack, there's going to be our different sources over here. These would be coming from certain events, apps, data feeds, and maybe some legacy databases that we're moving over to the lakehouse. And those all go into the lakehouse. This is one place to get all that information. And across this place, there's going to be the different data orchestration tools. One would be Databricks workflows, in which we're sending data from the bronze, the silver to the gold level. And in between, we do a lot of cleanup. We do a lot of checks. We do a lot of transformation. So this is going to be part of the gold layer in Databricks. And then finally, the end users are going to be consuming this data. This will be the source of truth. And the way it's going to be used is through analytics, potentially in BI tools like Tableau, as well as ML and data science tools like TensorFlow and Python. So where are the issues that can arise? What types of issues can happen? So they can absolutely happen at this bottom layer. So events, apps, data feeds, and certain things that could happen are things like late data, schema changes, duplicate data. So we need to make sure that that is not happening or detect them as soon as they happen. But beyond that, issues can also occur during the orchestration workflow. Right? And this is something that I could talk a little bit about later in terms of the synergies of data quality monitoring and orchestration. But SQL bugs can happen, jobs can fail, which can go back to the lakehouse. And then finally, how this results, if there are data quality issues coming from the sources or from orchestration tools, is this will impact end users. In a good situation, that means that dashboards might be broken, our metrics might be missing, the data isn't there for machine learning models. That's best case scenario, because at least users will know that something's up, and they'll have to go back to the data engineers to have it fixed. But worst case scenario, those metrics are misleading, or we have data, but we're running machine learning on faulty data. And then ultimately we would make wrong business decisions based on that data.
Got it.
So, oh yeah, did you have a question?
No, go.
Okay, cool.
This makes a lot of sense, and it's nice that you have very specific items that people on this show today can relate to, because we've all seen all of those problems and we understand what happens, as a result of those problems. And so it does make sense to avoid them. And you're saying that, but to avoid them, there has to be a synergy between how the workflows work and how the data quality works. Could you explore that a little bit more?
Yeah, sure thing. So on the Lakehouse, we can monitor at any different type of level. We could do it at the gold level, the source data bronze, at any different place. Now, blanket monitoring there is going to be good, but there are going to be cases where we specifically do not want to move data from a raw data set over and publishing it to the gold standard data set where people are accessing. That's going to be really important for very critical issues. So the way in which we can synergize that with Databricks workflows, for example, or other orchestration tools, is when a job runs, let's say we're moving something from the bronze layer to the silver layer, we want to run data quality checks on that silver layer after the transforms have been done. And if a very severe data quality issue is found, we want to halt the process so it doesn't go over to the gold layer. So in combination, we could save end users from getting faulty data that can strongly impact the business. Some issues, we might not want to delay data. We might want to send it through anyway. They might be insignificant. And that's why there are different levels of checks that I'm about to head into in a little bit.
So that makes sense for how it needs to work, but we're still talking about a lot of different data sources and a lot of things that need to be monitored. How do you do that?
Yeah, so that's a great question. And that takes me to how we would monitor data quality. And that would be at the Lakehouse level. So data quality monitoring, ideally, we would do it at the Lakehouse level because that's where the source data is, the transformed data, the intermediate data, and it's the source of truth. This is ultimately what end users are going to be using. And it's kind of like a rain catcher. It's going to catch everything from upstream. Now, where this becomes extremely critical is in the Gen AI space. So as AI is coming up, we need to be able to enable data quality across a warehouse. So it's always been the same thing. If we have garbage in, it's garbage out. So that's been true for creating dashboards. It's been true for machine learning models. It's going to be true for LLM models as well. So we all agree on that. But the new thing is with LLM models is going to compound much, much more. LLM is going to expand the scope of data questions in the Lakehouse, where there's historically been a bottleneck on technical skill set. So the bandwidth of data engineers, for example, in creating certain data products. So there's now going to be data that is unlocked that users can access because it's going to be much more accessible through LLM models. Now, usually on that data, at least if we have base level monitoring, there is going to be some type of operation flow monitoring at a high level. We're making sure that the data is arriving on time, that it's complete, and hopefully that we're looking at schema drift for those tables that end users generally don't use that much. That would be a foundational monitoring. But now with all of those tables being accessed because of LLM models enabling lots of different users, with those tables now being used for actual analytics, we need deeper monitoring in an automatic way. And we need that now. We can't start setting up a bunch of checks with putting that workload on the data engineers. They have a lot going on already. There's going to be lots of tables that we need to scale to in an automated way.
So as we broaden out the data uses, or the data that may be used, that may be important for AI modeling, then we need to broaden out the quality. We need to expand the orchestration, and that needs to be done together.
Yeah, exactly. So we need both broad monitoring and deep monitoring for across the entire lakehouse, especially as LLMs come and are implemented. And then the second part is ideally we would be doing that in conjunction with an operator, with our Databricks workflows. We want to make sure we're catching significant issues as early up in the lakehouse as possible so that we don't send bad data downstream that business users will ultimately be making wrong decisions on. So I would like to talk a little bit about what a comprehensive monitoring solution would look like.
Sure.
And this is going to be an approach that leverages lots of different categories of checks on our data. So at a high level, hopefully this is already in a data quality monitoring lakehouse, is table observability. So this is things that, like I was mentioning before, such as I need to make sure my data is coming through on time, that it's complete, I have the expected number of records there, and there's no schema drift. So that should be a blanket across every table. And then we have our validation rules. So these are what we're all familiar with. These are the things where we have very deterministic business logic or other rules that we need to enforce. So again, going back to an example of a credit card company with social security numbers in a column, those need to be there with every single record. We can't allow any individual record to not have that in an accurate way. So this ensures the data is perfect on those very targeted issues, and we can find pre-existing issues with those. We're not just looking for data drift for the new data that's coming up. But like we were talking about before, these are really hard to maintain at scale. We can't have a validation rule for everything that could go wrong in every column and every table, especially as data changes. Where the next layer comes in is metric anomalies. So these monitor significant changes in things like metrics. So think business KPIs that we would see in a Tableau dashboard or in a machine learning model, the average transaction amount. Maybe it's the sum of my total sales on a monthly basis. So these are great for this KPIs where we're looking at a high level to make sure that there's no significant drift. Maybe I don't care if one or two values are missing in a table of 1 million, but I do care if there's a significant change because that is going to impact our business decisions. But even these, as they move with the data because they can use time series modeling, even these are going to be susceptible to alert fatigue. They're using confidence intervals and they'll suppress that. But with every additional check that I create, there's nothing that happens but a further increase in false positive alerts, just statistically speaking. So how do we solve that? These three are going to be good for a pretty solid data quality monitoring solution. But the last part is through unsupervised machine learning. And this is a way in which I don't have to create a check for everything that could go wrong, regardless of whether it's a validation rule or a metric. I can get deep monitoring on every single table by default without any configuration. And these are going to be finding things without any setup. And they're going to be detecting significant drift. They can find these metric anomalies, for example, as long as they're very significant. The only issues are not as targeted. So that's where we still need validation rules and metric anomalies.
Sure.
But the additional part of unsupervised machine learning that is absolutely critical to the new age data quality monitoring strategy is that it can find the unknown issues. So even if I did have the time, even if my organization could create a check for anything we think that could go wrong in the data, there's still going to be a subset of data quality issues that we wouldn't know to look for. And so unsupervised machine learning can find that.
And that really gives you a chance to scale, because otherwise we're kind of constrained by our abilities, the staff, to implement the first kinds of things. We're really bringing the power of compute and machine learning to address this problem at these unknown unknowns and deal with the scale required in the AI world.
Yeah, that's exactly it. We need to be able to scale in the enterprise lakehouse, and we could do that with this unsupervised machine learning. Now, for those checks that we absolutely need to have for like KPIs that are extremely important and validation rules that we need to enforce for every single record, I want to do that in a self-service way. I need this to be able to be across different data users, like data engineers, data scientists, analysts, because they're going to be the experts in their data. They will know which metrics are important. So what we'd want, like in Anomalo, is a no-code or low-code way to add those checks. And this would just be in a point-and-click way.
Yeah, and that kind of addresses the same challenge we've talked about with Pradeep about, having a bigger extended team available to solve the problem and bring different expertise in, not just forcing everything through a very constrained and overburdened data engineering team, but bringing the business knowledge and that sort of thing.
Yeah, that's a great point. And I think that overburdening of a data engineering team, that brings me to my last point of a comprehensive approach to data monitoring, which is a way to quickly resolve issues. So we need a way to get to the root cause of an issue. And this is something, when I was a data engineer, 50% of my time was dedicated to figuring out why data quality issues were happening, where specifically in the data it was occurring. So this is why we need an automated way of getting a root cause analysis. And in Anomalo, it will generate an automated root cause analysis when a check fails. In this particular example, it's just showing that all the data quality issues are occurring for when the state is in New York, whereas only a portion of the non-issues in the data are occurring in the venue state of New York. So this gives high correlations and shows the over indices in when a data quality issues occurs. And so I know where to target my data. In this example, it's the New York records.
I really like the fact that it starts out with a very simple explanation of what the heck's going on, and then takes you down into, the data facts.
Yeah, exactly. I would say this is, single-handedly getting an automated root cause analysis is probably the most important way and the easiest way to reduce the amount of time in data quality monitoring and fixing issues. So even if I had a platform that only allowed me to create validation rules and key metrics, this would be worth it for that platform. Just having access to this root cause analysis. It's going to speed up the time to resolution dramatically because it's automated. And it does this in a very computationally effective way where it's using samples and rich visualizations. So users know immediately what's happening rather than having to do a lot of digging. And then it provides a way to do triage and resolution workflows, such as pushing this up to a ticketing solution like Jira. So someone can track the ticket there and then immediately resolve it because they get these visualizations.
Well, I think, having been involved in root cause analysis, so much time is spent just trying to understand the problem. And then the people that need to be involved in solving the problem, the business people and the technical people, finding a language they can both speak in, huge amount of effort in that front. So I can see why your customers really like this. Great. And so speaking of customers, let's switch gears for a moment and talk about some of customer examples and use cases and lessons learned and that sort of thing. Pradeep, why don't we start with you? Can you tell me about some, any customer stories here about using Databricks, Lakehouses, and orchestration platforms together and doing that for their AI initiatives? Share some of the examples and lessons learned.
Yipit data. So they're basically a trusted source of insights from alternative data from the world's leading investment funds and companies. So they analyze a lot of data points, like billions of data points. And you can already imagine like why data orchestration would be essential to their business. So historically, they used to use Apache Airflow, and it orchestrates all the tasks on top of Databricks, and some of the tasks outside as well. And what they basically went ahead and moved to Databricks workflows. They're moving away from Apache Airflow. They did this to basically increase the data quality and reliability, and also productivity and agility, which we briefly touched upon, and of course reduce their costs and optimize their performance. Because if things are orchestrated outside of the Lakehouse platform, and you are orchestrating tasks within the Lakehouse platform, it could be siloed in a sense, and it's really hard to optimize as a whole. That's what Databricks workflows would enable you, right? So that's what they did, and basically they did report a lot of benefits from saving engineering time, which I believe I mentioned. It's not siloed in a different platform anymore. It's part of the Lakehouse platform. All personas are able to see it, access it, and certain personas are able to edit it as well. So the visibility is very important for orchestration, and that really helped UP Data save engineering time. It also reduces onboarding time, because if it's a separate platform, you need different capabilities. Airflow needs different capabilities, and it needs a different type of expertise, and it does take good amount of onboarding time to onboard engineers to be able to do that. So basically, UP Data was able to reduce that as well. And of course, in turn, they were able to enhance customer satisfaction, because now they're able to manage all of this a lot better. So that would be one, one good customer story, in my opinion. There are other customers, of course, like Grip or Vigio, several other customers, but to name a few.
Well, it seems like you're not going to be able to scale if you can't get that data engineering level a workload reduced, and you're always going to be adding new sources, so that onboarding needs to be made to the extent that you can make it consistent. Improves your ability to achieve that.
I don't know if the data engineering workload would be reduced per se, but I would say at least it's not going to exponentially increase, right? So it at least helps stop from it being exponentially increased, and it's happening across the enterprises today, and it's critical. So
so basically, you improve responsiveness, and that responsiveness, as you say, turns into customer satisfaction. Thanks. Zach, you want to talk about some customer case or two that kind of showcases this data quality and data orchestration environment, data lakehouse environment?
So one of our customers, Discover Financial, the credit card company in the United States, so they have a very significant problem statement in their environment, which is they have 125,000 business data columns. And there's quite a lot, and they're all in different tables of various sizes. And what they found before implementing Anomalo is, for putting up a calculation, a data quality check that isn't basic in terms of data freshness or that it's complete, the count of number of records, talking about actually making sure values are following a certain role. They found the level of effort generally for any given column is about 40 hours for a data engineer. And that might mean 2 to 3 checks on a given column. And 40 hours seems like a lot. It's like, okay, what's going into 40 hours? It should just be, I want to make sure that there aren't too many nulls. But this accounts for the column's data characteristics changing over time. So when that happens, let's say it's normal for 0.1% of the values in a column to be null. And then over time that drifts up, and it's actually normal and okay for 5% of those values to be null. I need to adjust models. I need to adjust my thresholds so I'm not getting alerted every single day on the fact that 5% of the values are nulls. So it's going to take a long or a significant amount of time to maintain those checks. And not only that, we have to account, or they had to account for the handoffs required between data SMEs and engineers to test and implement the check in production. So this was a significant issue. And to talk about the actual scale with those 125,000 columns and 40 hours per column in data quality, that was about 5 million hours in what they projected data quality monitoring would take out of any given data engineer. In total across all their data engineers. And generously in their organization, they had about 100 dedicated data SMEs, and that's still over 50,000 man hours per person. So 50,000, even if we have 2,000 productive hours a year where everyone is completely efficient on this, that means that it's still going to take 25 years to achieve 100% data business quality. So now going 100% of the way, that we could take it back a little bit by decreasing scope. Not everything is going to be as important as other things. We could also reuse data quality rules where important, but ultimately this is going to be throwing more people at the task, and longer initiatives they just saw being futile in a data ecosystem with ever-changing people, processes, and technologies. And the ultimate challenge they had is the data characteristics are constantly changing, and DQ rules must be adjusted. So that's the issue. Now, how were they able to solve this? The main way is through the leveraging of unsupervised machine learning. So they don't have to create hard and fast rules that are deterministic on every single 125,000 columns. Like we were talking about before, it's difficult to scale that, to say the least. So with unsupervised machine learning, they were able to get deep coverage without having to add a custom check for anything that could go wrong. And with this unsupervised machine learning on a table by table basis, it will just take minutes to get it set up. So this is much more scalable anomaly detection for them, for thousands of data sets, hundreds of thousands of columns, and billions of records. We have another customer that one of their tables has over 40 billion records a day. So with all that in mind, Anomaly makes sure compute is going to be very efficient in the Lakehouse. That is absolutely critical. The second part that dramatically reduced the amount of time in their data quality is the user experience. That needs to be top notch. We can't have something that's going to be janky, something that's hard for end users to understand. Ideally, something that is so good that lots of different data users can self-service in their own way. So not just the data engineers, but data scientists are going to be experts in their models. They know which features are going to be really important. So shouldn't they be able to go in and create their own check? Analysts are going to be experts in the dashboards they're creating, or even product owners who are looking at those dashboards are experts in those metrics. So they need a way to create checks on those metrics. Otherwise, they'd have to go through data engineering, and that's going to be a bottleneck. So what Discover found with Anomalo is that the no-code checks, there's going to be over 100 out-of-the-box no-code or low-code checks available, and it's just point and click. Users are able to self-service. So they've been using Anomalo for 2 years now, and they're scaling this enterprise-wide, and they continue to have more and more adoption every year.
Wow, that's incredible. 25, you said 25 man years. It's just an overwhelming workload. It's interesting that you use the term people, process, and technology. And so much of today's conversation has been about people and process, and integrating processes, data quality, data orchestration processes, and opening up through new user interfaces and intelligence, opening it up to more people who could help solve the problem. Kind of a common theme there. Any like one or two words of advice or one or two key points of advice that you would take away from the customers? Pradeep, what would, if a new customer is kind of going down this pathway today, what would be a couple of important tips that you would advise them about in order to help ensure their success?
So we spoke about unifying the entire data and AI lifecycle. That was the most important piece. To become a data forward organization, where AI basically enables every part of your business, right? So to get that state, you definitely have to unify your data and AI lifecycle. And adopting a lakehouse really helps. But of course, choosing a lakehouse is the hard part. And there is no other lakehouse out there that's complete. Basically, Databricks is the only lakehouse platform that's a complete lakehouse platform. I did explain what a complete means, right? Where you have to, this lakehouse platform should be able to, you should have all the capabilities that, I've listed previously. So that's really essential. And the next thing is, try to avoid vendor lock-in. Of course, we are a vendor, but what I'm trying to say is, for example, with Databricks, we all of our data is stored in Delta Lake, and Delta Lake basically uses open source Delta format. You could basically store your data in any format, doesn't matter, but Delta format is a recommended and optimized way of storing data within Databricks. And Delta is open source, so you can a lot of other platforms support it. So it's not really that your data is logged into a proprietary data format. So that would be my recommendation.
So three things: think holistically, get a complete platform, but make sure that platform's open so it remains flexible. Zach, anything particular if someone's thinking about data quality at scale and what they should really, two or three things they just absolutely need to think about?
Yeah, so I've talked with over 100 different companies at my time here at Anomalous so far, and the main issues I see are with regards to being able to scale and making sure that notifications coming in are the important ones. We're not getting too much noise, because that's when data quality end users are going to start checking out, and then nothing's going to be getting fixed, and we don't have any data quality tool at all. So with scale, that's going to be the most important. This new world of AI coming out in Databricks, the Lakehouse, the access to different tables that have never been used before by lots of different new end users that aren't as technical, that is going to create problems if we don't have a very thorough and deeper data quality monitoring solution. If we're just looking at pipelines, it'll be easy to determine if the data is there, if no result is being returned. But what won't be easy to determine is for an end user, especially non-technical end users, it won't be easy to determine if what is being returned is right. And they're going to be making business decisions. So the most important thing is to have blanket deep data quality monitoring, deep data drift across an entire lakehouse. And the lakehouse, like Databricks, is going to be the best way to scale with Gen AI. The other two parts are for the metrics that are extremely important. We need to empower users to be able to self-service. We need a way to have them point and click to create their own checks and get alerted when those particular metrics are showing that there's anomalous behavior. And the last part is we need to empower data engineers to get to the root cause as quickly as possible. Now with this expanded number of tables and files, for example, that LLM models will start using in Databricks, we need a way to fix them even quicker. Otherwise, we're going to have to dramatically increase our headcount in the data quality, the data engineering department. So ideally, like in Anomalous, there would be an automated root cause analysis to do that.
Okay, so root cause analysis, getting a bigger team with some friendly user interface, and then just having the horsepower to do all of the different types of data quality monitoring that's required. That's great. Thank you for that summary. Guys, thank you so much. This has been a great session. I think we've met our goal, which is to talk about why data quality and data orchestration in this Lakehouse environment is so critical to achieving AI at scale. We've talked about people, we've talked about process, we've talked about technology, we've talked about bringing it all together. And hopefully the listeners today have gotten the benefit of all your expertise, and thank you for sharing that. Again, if you want more information about either Anomalo or Databricks, you can go to their Insight Jam solution spaces, and of course you can go to their websites as well, where you can find additional resources. So thanks again, guys. We really appreciate it.
Thanks, Bob. Nice discussion. Pradeep, Zach, thank you as well. Well, there you have it. Another expert roundtable in the books. We want to thank Databricks and Anomalo for their participation, and we certainly appreciate your attention as well. Until next time, I'm Doug Atkinson here at Solutions Review. Thanks for being with us.